Number 3.2 says that the tins of paint Petra buys can paint 14 square meters or can paint 14 square meters per 500 ml. How many 1 liter tins should she buy if she needs to paint 90 square meters? So basically, guys, what I want you to realize there is that we are given a rate. Can you see the number 14 is measured in meters squared, which means it represents area, and then the number 500 is given in milliliters, which means it represents volume. So we've paired together an area and a volume, and we've kind of grouped them together. We've related them to each other, and these two kinds of units, area and volume, seemingly have very little to do with each other if you look at them as individuals. But in this scenario, it's describing something very specific about this scenario, is that the amount of paint that we need to use can be is directly linked to the size of the area that we're painting, right? So we're comparing two numbers, we're grouping these two numbers together that have different units. So it's something that we call a rate. You guys should be familiar with that term. So I have 14 square meters and I have 500 milliliters, okay? And remember that rates can be treated the same as ratios, okay? What I'm going to say is that we are comparing area and volume. And they told us that 14 square meters, and they bound that number with 500 milliliters. Then they asked us a question. They said, how many 1 liters? So what are they asking here? How many 1 liter tins? They're asking for volume. Am I not lying? Am I lying? That's not for volume. Okay, should she buy if she needs to paint 90 square meters? And they've given us an area. So we're going to take the area unit, which is 90, and we're going to put it underneath the A value. And mind you, the units are the same. It's square meters and square meters. That's why I don't need to convert anything first. Then we don't know. Obviously, they said how many 1 liter. Or they said what volume, in other words. So we don't know. So we're going to put an X there. Then you're going to do something called cross multiplying, where you say X times 14 is 14X. And you're going to say 90 times 100 is 45,000. Then we're going to divide by 14 so that we can solve for X. Okay. And then we end up with X is equal to 3,214,29 milliliters. Remember that we had the volume in milliliters. So even at the end, when we calculate, the volume will still be in milliliters. Okay, now that's not the question they asked us. Remember, with these story type questions, you need to make sure that what you are writing as your answer is related to what they asked you as a question. They said, how many 1 liter tins? First of all, how many liters is this? If you go back to King Henry, you'll see that we're converting. King Henry died a miserable death called measles. If only this thing could move away. Yeah, called measles. Ooh. Called measles. We're converting from milliliters to the middle unit, which this can be liters, grams, and meters. We're converting from here to here. So how many jumps are we going? 1, 2, 3. So we're going to divide by 1,000. So we're going to say 3,214,29 divide by 1,000. In other words, we can just move that comma up 3 times to the left, and we're going to have 3,21 liters. So it's going to be 3,21 liters. Is that answering the question that they asked us? Still, we're not answering the question they asked us, because they said how many 1 liter tins. Now, if you are using the normal rules for rounding off, you would say 3,2 rounds off to 3, right? But now you have to think of this question logically. If I need roughly 3,2 liters of paint to paint 90 square meters, and I buy 3 1 liter tins of paint, am I not going to be short a little bit? So even though logically we should round off to 3 liters, we're not going to do that. We go, not logically, but according to the rules of rounding off, 3,2 rounds down to 3 liters. Using logic, we need to round it off. So we're going to say 3,2, and we're going to round it up to 4 1 liter tins of paint, and that will be the answer. Okay, Cool bananas. Study that. Okay, I'm going to erase this now. Okay. Next question says that Next question says this. Study the advertisement for soft drinks. Consider the price for 6 cold drinks in both options. Determine which option would be better. Okay. The first option, let's say option A. Hey, bro, what's this? Hey, how do I get rid of it? How do you get rid of this thing now? Where did it even come from? Okay, it's gone. Okay, yeah, no. So we get given option A, which is 12 cold drinks. 12 cold drinks for 108 rand. Again, do you see that rands and milliliters are or rands and number of cold drinks are being bound together to rate? Okay. Then we get given option B, which is 24 cold drinks at 210 rand, and we have to compare which one is the better option. Okay, it's very logical, this thing. In fact, if you didn't already see, we need to compare the same number of cold drinks. We can't say, yeah, the 108 rand is better because the number is smaller. It's also buying a smaller number of cold drinks, so that is logical. But if we were buying the same amount of cold drinks at these two different rates, which one would be cheaper? If I multiplied the 12 by 2, I would get 24. But then I'd also have to pay 2 times 108. That would be 216. So on option A, 24 cold drinks would cost me 216, whereas on option B, 24 cold drinks would cost me 210 rand. Then don't forget to answer the question. Therefore, option A is the better option. Okay, I hope that makes sense. It's not that bad, no? Next question says this. A 5-meter ladder rests against the wall. The roof of the ladder is 4 meters from the wall. How high does the thingy touch? How does the ladder touch the wall? So I want you guys to imagine, there is the wall. There is the ladder. Okay? Forgive my drawing. There's the ladder there. There's the wall. Obviously, the ground is horizontal. Okay? And do you see that any horizontal line and any vertical line, the wall is obviously vertical. I don't know how the walls are at your houses, but my walls are vertical. Okay? And the ground is, typically horizontal. So we can just assume that, or we can say any angle between a vertical line and a horizontal line is always 90 degrees. Okay, so what are we looking at here? We're looking at Pythagoras. They told us the length of the ladder. It's a 5-meter ladder. So we can put 5 meters here. And then they told us that the foot of the ladder there's the foot of the ladder. It's 3 meters away from the wall. So we're going to say that's 3 meters there. I want to know how high does the ladder touch? Very, very simple and easy. We're going to use Pythagoras, which says that the hypotenuse squared, okay, which now I want us to refer to the hypotenuse as r. Hypotenuse squared is equal to the side squared plus the other side squared. It's the sum of the square of the other two sides. Okay, so r squared and the other two sides we call x and y is equal to x squared plus y squared. The next time you write Pythagoras, I want you to write it like this. What is the hypotenuse? It's the side opposite the right angle. What's the side opposite the right angle here? It's the ladder. So we're going to say 5 squared is equal to x squared is one of the sides, which is going to be 3 squared, plus the other side I don't know, so that's going to remain y squared, right? Then we can just use normal algebra to solve. We can say 5 squared is 25 is equal to 3 squared is 9 plus y squared. Then I can take the 9 over. It's positive 9 on the side, so when it goes over, it will be negative 9. 25 minus 9 is 16, which is equal to y squared. Then how do I get rid of a square? I square root on both sides. So that means the square root and the square cancel out, so I'm left with y. And the square root of 16 will be 4 meters. That means if the ladder is 5 meters and I put the foot of the ladder 3 meters away from the wall, it will reach a height of 4 meters. Okay. Then, can a triangle of okay, can a triangle with sides of 7 centimeters, 24 centimeters, and 25 centimeters be a right angle triangle? And they've given us here the test. Test the longest side and the 2 shorter sides with the formula. I want you to know one thing about the hypotenuse. It's longer than all the other than the other 2 sides. In length, the hypotenuse is longer than the other 2 sides. So look at this triangle here. Okay, they've given us, okay, let's just draw a triangle without drawing a right angle. They've told us that one of the sides is centimeters, 7 centimeters. The other side is 24 centimeters. Obviously, this is not drawn to scale, ne? And then the third side is all, and can you see the 25 is the longest? So I'm going to put that one opposite what should be the right angle. I don't know if this is the right angle or not, but I'm going to put the longest side opposite what should be the right angle, right? According to Pythagoras, I know that the square of the hypotenuse should be equal to the sum of the square of the other 2 sides. It should be, okay? This must be proven. You're not going to start off with this. No. You're not going to start off by writing this, okay? I'm just saying that that is what we need to prove. So let's calculate what r squared is. R squared would be 25 squared, which if you calculate, you'll get 625 centimeters. Centimeters or centimeters squared? Anyway, centimeters squared, whatever. Okay. No, I'm not going to confuse you. It is centimeters squared, but I don't want to confuse you. Just write it as centimeters. Okay. Then x squared plus y squared. Now, if I get the same answer if I get 625 here, then I will know for sure that this is a right angle triangle, because then it means that this will be true. It means that r squared will be equal to x squared plus y squared. Does that make sense? So I'm going to calculate. X squared plus y squared is equal to 7 squared plus 24 squared. Now we're going to calculate 7 squared plus 24 squared. 7 squared is 49. 24 squared is 576. Then 49 plus 576 is 625. So you can now say, therefore, r squared is equal to x squared plus y squared. And therefore, what is the name of the triangle? The triangle is a right-angled triangle. Exactly. Are we together? Because it follows the theorem of Pythagoras. Okay. Amazing. Who said math is difficult? Right, last question I'm going to do. Study the diagram and answer the questions. Determine the circumference of the circle at the top of the cylinder. Okay. For this, guys, I don't know what to tell you. The only thing you need to know is formulas. So for 5.2.1, the formula for circumference is 2 pi r. Okay. And you're just going to literally substitute 2 pi. The radius is given to us there as 2 centimeters. If you don't remember the anatomy of a circle, the line from the center to the edge is called a radius. The line from the center, from one edge of the circle through the center to the other edge of the circle, is called a diameter. And the diameter is 2 times the length of the radius, or you can say the radius is half the length of the diameter. Okay. So they've given us the radius. Can you see that they said they highlighted this line in radii, and then they pointed at the line. It starts from the center of the circle and it goes to the edge, and they've given it to us as 2. So we know the radius is 2. There's no calculating that you need to do there. Okay. And 2 times pi times 2 is 12, comma 5, 7. What is the unit? Centimeters. Circumference is the same as what? Perimeter. It's just that when it's a circle, we call it circumference, because mathematicians like to be fancy. Okay. Don't shoot the messenger. Jake wants to paint the triangular prism. Okay, Jake wants to paint the triangular prism, which is the box part, without touching the cylinder. Determine the total outside surface area he will paint. Now, guys, you need to realize one thing. Let me see if I can make this very clear for you. Can I choose white as a color here? Okay, I can't. But I want you to know that this is going to disappear. This is going to disappear. Or, no, let me rephrase what I want to say. Ne? Let me say it nicely. Okay. What I want to say is this. Is that I'm going to calculate the surface area of the box. But I'm going to minus, in fact, surface area of box. And I'm going to minus the area of the bottom circle. Do you guys understand that I won't be painting that circle that's touching this circle here? Jake won't be painting the circle here. Because why? It's touching the cylinder. So there's no way he can reach that circular part. So we're going to calculate the area of the whole box, the surface area of the whole box. And then we're going to calculate the area of the bottom circle, and we're going to minus the area of the bottom circle from the surface area of the box. Now, surface area is a very simple concept, okay? It means the area of this plus 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 the area of this at the top. Now, you need to work smart and not hard, okay? This front side here has got an identical twin, which is the back side. Okay, this side here has got an identical twin, which is this other side. And this bottom side here has got an identical twin, which is the top side. So as long as you know the three, the front, the side, and the bottom, you're just going to multiply them by 2. Now, let's look at the front. Let me just erase so that everything can be clear. Ne? The front, what are the dimensions of this front rectangle? So let's say total surface area is going to be equal to 2 times, for the front is going to be 9 times 5. Ne? Plus 2 times for the, let's say, the right side. This right side here, it's going to be 4 times 5. Can you see that? 4 times 5. Plus 2 times the bottom side will be, this bottom here will be 9 times 4. Can you see that? 9 times 4. So I'm going to say 2 times 45 plus 2 times 20 plus 2 times 36. Able 45, ne? Sorry. So it'll be 90 plus 40 plus 72. It's going to be 130, 202 centimeters squared. It's area, ne? So it's going to be in centimeters squared. That is the area for the box. Remember, I want to minus the area of the bottom circle. So I need to calculate the area of the circle. Area circle is going to be equal to, you must just remember the formula. It's pi times r squared. So it's going to be pi times the radius, remember, was 2 squared. 2 squared is 4. Now, it just so happens that 2 times 2 is also equal to 2 squared. So the area and the circumference are equal in this instance. It'll be 12,57 centimeters squared in this case because it's area. Now we're going to go back to this part where we said that the area, the surface area to be painted would be the total surface area of the box minus the area of the bottom circle of the cylinder. And then we're going to say, therefore, it's going to be equal to 202 minus 12,57. Then what do we get? 189,43 centimeters squared. Okay, guys. Yeah, that's all I have for you. I hope it helps.